Science is often presented as the purest form of rational inquiry. Evidence accumulates, experiments decide, the best explanation wins. But if that were entirely true, scientific revolutions would not be so rare. Today, it seems obvious that science operates within frameworks, that researchers share assumptions, that institutions resist change, that revolutions are rare. But in 1962, when The Structure of Scientific Revolutions was published by Thomas Kuhn, this was deeply unsettling. Science was widely portrayed as purely rational, steadily cumulative, self-correcting through logic alone. Kuhn challenged that image, and in doing so he changed how we think about knowledge itself. But did he go too far? Kuhn's central insight is simple but powerful. Science does not primarily advance by constantly testing and discarding theories. Instead, it operates within what he called paradigms. A paradigm is not just a theory. It is a shared framework, a set of assumptions, agreed methods, accepted standards, and a common language. Most scientific work is what Kuhn called normal science. It is puzzle solving within the paradigm. Scientists do not wake up every morning trying to overthrow Newton. They refine, they calculate, they extend, they solve anomalies within the structure. This means science is conservative by design, and that conservatism is not irrational, it is stabilizing. Without it, research would fragment endlessly. Every anomaly would trigger chaos. Shared standards make cumulative progress possible. This was Kuhn's first major contribution. Science is an institution, not just a logic machine. But paradigms do not last forever. Anomalies accumulate, not immediately and not easily. Scientists often reinterpret anomalies. They assume error, they double down, but sometimes the tension becomes too great, crisis emerges, and eventually a new paradigm replaces the old one. This is not gradual refinement, it is revolutionary change. Kuhn argued that these revolutions are not just theoretical updates. They are shifts in standards, language, what counts as a problem, what counts as evidence. He called this incommensurability. Competing paradigms may not be directly comparable by neutral criteria. They see the world differently. That idea was profoundly disruptive. Where Kuhn becomes controversial. If rationality is paradigm-bound, if standards shift with frameworks, then how do we say one paradigm is closer to truth? This is where critics like Karl Popper pushed back. Popper argued, science advances by bold conjectures and refutations. A theory must make risky predictions. It must expose itself to falsification. Truth pushes back. Kuhn responded, in practice, scientists do not abandon paradigms at the first anomaly. They protect them. And he was right about that. But here is the tension. If paradigm protection becomes insulation, when does stability turn into stagnation? Kuhn showed that science is structured, but structure introduces power. Paradigms influence funding, hiring, publication, and prestige. When a research program dominates institutional channels, alternative approaches may struggle, not because they are false, but because they are marginal. This does not mean science is corrupt. It means science is human. And like any human institution, It balances stability against correction. Too much openness leads to fragmentation. Too much rigidity leads to insulation. Science survives in the tension between the two. There is another implication of Kuhn's work that is rarely stated directly. Paradigms are not only intellectual frameworks, they are also communities of authority. Every paradigm develops experts, researchers who define standards, editors who decide what is publishable, institutions that distribute funding and prestige. In other words, paradigms develop elites, not conspiratorial elites, functional elites, people whose judgment stabilizes the framework. This is not necessarily a problem. Without authority, scientific institutions could not function. But it does introduce attention, because the same structures that protect knowledge can also slow its correction. When paradigms become too rigid, criticism moves outside the institution, and revolutions become more likely. Kuhn described this process inside science. But the pattern should sound familiar. It resembles the circulation of elites described by Pareto, and the institutional dynamics observed by Burnham. Structure stabilizes systems, but stability always risks becoming insulation. Kuhn taught us that knowledge does not float free from institutions. Frameworks matter, communities matter, stability matters, but so does judgment. Because there is no algorithm that tells us when to protect a paradigm and when to abandon it. That decision requires discernment. In an age where ideas multiply faster than ever, where models can be generated instantly, the challenge is no longer producing frameworks. It is selecting wisely among them. Science faces this tension. So does civilization. Kuhn was right. Science operates within paradigms. But paradigms are not the whole story. Reality still pushes back. Truth is not created by consensus. And correction, though difficult, remains possible. The real question is not whether paradigms exist. It is whether we can maintain the balance between stability and reform, commitment and openness, intelligence and judgment. Because, in the end, no framework can replace responsibility. Not in science, and not in society. Paradigms guide thought, institutions guide power, and both must remain open to correction. The question is not whether structures exist, it is whether they can remain open enough to change. I'll see you in the next episode.